Hello, good evening. In today's introduction to a paper, I'll be presenting improved Arabic-based phrase chunking with a new enriched part-of-speech tag set. This paper was presented in 2007 in Proceedings of the 5th workshop on important unresolved matters in association published by ACL, Association for Computational Linguistics. So the main purpose of this paper is to develop Arabic-based phrase chunker, or BPC, and the approach that they followed for this research is machine learning by using SVM with features of morphological features and also enriched part-of-speech tags. And the result was an improved state-of-the-art performance in base phrase chunk using the new set of part-of-speech tags that they have designed. So if we go to the details first, let's start off with what is base phrase chunking. It's a process by which adjacent words are grouped together to form non-recursive chunks in a sentence. The phrases may be verb phrases, noun phrases, adjective phrases, and so on. So an example would be as given here: I would eat red luscious apples on Sundays. So the chunked output of this sentence is I could be a noun phrase, would eat is the verb phrase, red luscious apples is the noun phrase, and on Sundays the prepositional phrase. So a normal text is chunked into this kind of phrases. And the main applications, or some of the main applications of chunking, are like information extraction, semantic role labeling, machine translation, and so on. So for this research, they followed supervised approach, whereby the input training sentence are tagged manually. So the scheme that they have used for this research is called IOB scheme. Here the I stands for inside of a chunk, O stands for outside of the chunk, and B is the beginning of the chunk. So an example is depicted here: I would eat. So I is the beginning of the noun phrase, would is the beginning of the verb phrase, it is inside of the verb phrase, and so on. So they modeled the chunking problem as a classification task, and they applied supervised SVM algorithm. And the reason that they have specified for following such an algorithm is because of its capability to handle a large number of features. And first they made part-of-speech tagging in the pipeline of the process, and then after finalizing the part-of-speech tagging, then they went on to chunking. So in Arabic, as in other Semitic languages like Hebrew, Tigrinya, Amharic, the morphology is very complex. They have rich morphology. So the words have markings of case, gender, number, definiteness, mood, person, voice, tense, and other features. So the words, when they have combined features like this, they could get complex. The data set that they have used is Arabic tree bank, and for this tree bank, the original tag sets contains around 2,000 tags. So individual tag sets can get very complex in order to specify all of the information which is embedded or indicated in a single word. So in order to reduce these tag sets, they designed 25 tags which consists of more or less the basic part-of-speech tags. But for this base phrase chunking study, the authors designed another new tag set which contains 75 tags. So here is a table which gives an example of how the tagging is done in these 3 different tag sets. So the fourth column, full, has noun and in addition other morphological features. Noun suffix, female, singular, case, nominal, and so on. But when you look at the RTS, which is the reduced tag set, it only contains information of the major part of speech tag, so noun. Then they designed another moderate part of speech tag which contains gender information, so noun and female, F. So this is basically the difference in the tag set that they have designed. So for the features in the part of tagging process, the ERTS, which is the 75 tags that they have designed for this research, they used this part of speech tagging set, and they were only able to use 57 tags for the research, though they designed 75 of them. So the window for the lexical features are plus or minus 4 character engrams. These are the suffixes and the prefixes. And for words, plus or minus 2 words around the focus word, and then 2 previous tags which forms a trigram. And the kernel is of degree 2, and they followed one versus all multi-class classification approach. For the base phrase chunking, they designed 10 different types of chunked phrases. So as we can see, adjective phrase, adverb phrase, conjunction, interjection, noun, preposition, predicate, and so on. And one O phrase for marking period which is outside of these phrases. So as I've said, the training data is derived from the Arabic tree bank, and they used a software called ChunkLink to flatten the trees to subsequent to a sequence of base phrases which are non-recursive. Non-recursive means noun phrases which does not contain noun phrases. But this is in the English context. Arabic is a different language, so noun phrases may contain noun phrases in order to be meaningful expressions or chunks. So the authors used this ChunkLink software, but they again processed the output of this software by using linguistic knowledge of Arabic syntactic structures. So these are some of the modifications that they have done. Idafa is one structure which marks possession in Arabic. So the output of the ChunkLink software was modified into this structure. Noun adjective is another structure whereby adjective follows a noun. And also other similar modifications were done for the output of the ChunkLink software. Pronouns, interjections, propositional phrases, and so on are modified. So after they modified these, they came up with the complete phrase types which they tried to classify or perform in this research. There are 10 of them: adjective vowel phrase, adverbial phrase, conjunctive phrase, and maybe the special ones are the number 7, which is predictive phrase, where the word an, which means is followed by a noun phrase. And then particles have also their own phrases, subjunctive constructions, and also the verb phrases. So altogether 10 complete phrase types. So as I've said, the feature sets are the part of speech tags and also the presence or absence of morphological features. So they tried to make variations of these two different features and see how the result comes up. So they had 10 different experimental conditions. One is the part of speech tag set, and another is either full or no feature or a combination of selected features. And the word context is plus or minus 2, so 2 previous words and 2 next words. And the tag is 2 previous tokens. So these are the feature sets. So they used 3 data banks which are of news type, of news genre, and the developmental training data and test data is as shown there. So for the baseline, they just tagged the words with the most frequent tag which is available in the training data, and the accuracy is 86.5%. When they used RTS, which is the reduced tag set containing only 25 tags, the accuracy was 96.15, and when they used the new tag set that they have designed, the accuracy was 96.13, which is a little bit reduced. For the phrase-based chunking, and the previous result, which was state of the art, was the score was F measure 91.44. But we can see in this table the current results outperform this state of the art result, and this is mainly due to better quality of annotations. So they used the Arabic tree bank, which was full tag set tagged, and then they reduced the tag set. So during the reduction process, when you reduce from the full tag set, you are effectively masking the different varieties or morphological features. So if you have full tag set, maybe there will be some potential errors while doing the tagging, but if it is reduced, for example, past tense and present tense, or past verb in the past form and verb in the present form, if they are masked, they will be only verbs. So the potential of making mistakes while tagging also reduces. So they say that the corpus that they were working with, because of the reduced tag set, had better quality. So these improvements are also attributed to this better quality corpus. So the conditions, they used all the different tag sets to make the experiments: the reduced tag set, their own tag set, and the full tag set, with features and also with the morphological selections: case, mood, person, definiteness, gender, and number. These are the morphological features that they were making variations in order to see the results. So if we see the results here, for the reduced tag set 95.41, but then when they used the 75 tag set, it increased it a little bit. It's 96.33, and so on. So even though the number of tag set was increased to 75, but we still see some improved results because of the reasons that I have tried to mention, like the consistent corpus that they were working with. So our results from the new part of speech tag set outperform their counterparts in the old or the reduced tag set, and the ERTS, which is the tag set that they have designed with no features, with no feature conditions, outperforms all other conditions in the experiments. So when they eliminated all the features, they saw a better performing chunker, and the reasons for this were because maybe they say that the noise would also be reduced if the number of features are reduced, and maybe the encoded part of speech information without the features would have enough information for the classifier to decide the chunking possibilities. But either way, adding more morphological features to the RTS part of speech tag set also slightly improved the performance. However, when they added those features to the ERTS and the full tag set, there was not much improvement on the output of the chunker. So this is a table where they assessed the impact of more features by phrase type. So they have adjective phrase, interjection phrase, and noun phrase with the different tag sets: the RTS tag set, the ERTS tag set, and the full tag set. So if we see closely the results, for the reduced tag set, it started with 68.42 for the adjective phrase, but then when we see the ERTS case, mood, person features, it was 73.16. So when the number of part of speech tags increased, and also when more features are used, we see the maximum results. And similar also for the other phrases, the highest results were achieved with the new tag set that they have designed. So in conclusion, they achieved better performing results when compared to the state of the art, and they suggested that when you choose correctly the part of speech tags that you're going to work with, then maybe there will be significant impact on the actual result of the chunker. And also adding more morphological features in case of Arabic, because it's highly inflected language, increases the performance when the tag sets are reduced, but not when the full tag set are used, maybe because of the noise that was introduced by using more number of features. So that was it. Thank you so much for your attention.